There we go. So, if anybody has a question at any point in this room, I'm not going to see one of these, okay? Just because of where the monitors are. Put that hand right up there, okay? Sound good?
I mean, there's a gap in the so...
Yeah, I can see some of you, but like I've got like an aliasing interference pattern for some of you. So like some of you are hidden and some of you are not. So just, in the interests of, anyway. So, welcome to Java. Ooh. We are going to be studying probably, your first real taste of programming in this class. I would say that JavaScript client side will also be real programming, but this is where we're going to get into a lot of the really nuts and bolts theory of how programming languages are constructed. There is a reason that we learn Java, right? Java, in contrast to most of the other languages you will study here, with the exception of C#. C# is its own thing. You know what some people call C#? Microsoft Java, right? C# is very, very similar to Java. So there's a course in third semester that is a C# course, but it essentially functions as Java Part 2. So, you don't have to worry when you get there that, oh, I'm learning a whole new language from scratch. No, it's very, very similar to the stuff you'll be learning here. So, Java is a nice language to work with. The only problem with Java is it takes a long time to say anything in Java. It's a very verbose language. But, in contrast to many other languages that you will deal with, most particularly PHP, or hopefully you guys won't even take PHP, but JavaScript and Python, these are loose languages that are very kind of mushy on what the hard semantics are, right? Java is more strict, but you'll find that strictness is actually your friend. What the purpose of strictness in a programming language is it prevents you from falling into traps. That's why nice statically typed languages like Java end up being easier to develop large programs in than your sort of loosey-goosey Python scripts. All right, make sense? So, I am Dr. Nicholas Moore. I will be your instructor this semester. Very pleased to meet all of you. This is the course shell. Anybody know who this guy is?
Linux?
Not quite. That is Duke. He is the mascot for the Java programming language. This is actually an image that I did in AI. You can probably tell. I think he has the correct number of fingers, though. Wait, does he? No, he's got an extra pinky finger, I think. Maybe. So it goes. Anyway, so, Java. There we go. So, one thing right off the bat, I video record my lessons for this class and for client side as well. I then post them to my YouTube channel, which I think I need to post the link here. I'll get the link to the YouTube channel up here pronto. A couple of purposes for this. Number one, it gives you some reference material when you're studying for tests, right? Number two, you can listen to me back at 1.5 or even 2 times speed, right? Number three, it captions me. Sometimes that's useful. Sometimes I can be a bit of a fast talker. I apologize. It's just the way I was made. There's also a quite plentiful archive of previous offerings that I've done at this college, which you may make available to yourself. I do it a little bit differently every time, right? I like to think that I am improving as I go along, but you know, maybe history will tell a different story. But yeah, please feel free to peruse the archives for previous offerings. If you know you're going to be away and you want to do a little bit of work ahead, something like that, it's there for you, right? But that does mean that if you sit close to the camera, everything you say will be on camera, so just, you know, bear that in mind. Yes?
Are you gonna have like a lot of coding examples for us to practice on, or is it gonna be mostly like lecture stuff?
Oh, definitely we're going to be doing code examples. Yeah. So the structure of the
I remember Python. It
Yeah.
was so bad.
Our Python teacher, she had like no examples for us to practice on.
Python.
There were no assignments that we had to do. There were no actual coding examples, and half the class was spent structuring if structures.
We had 2 labs, one of which I lost marks on because I didn't use AI.
Both of the labs
Yeah.
were on coding with AI.
well,
kind of were assignments. They were just.
well, let me put it this way. As first programming languages go, Java's not a bad choice. Yeah, so the structure of this course, we're going to start with 2 weeks of reviewing the basics, all right? I'm going to pull you all the way up through if statements and loops and print statements and a few other things as well. There will be copious amounts of practice material, some of which we will be able to do in class, all right? My style is not to, you know, blast through the lecture slides in 20 minutes and then, you know, slap you on the back of the head, say go practice it, and then leave for the day. That's not what I do. I actually use the time. This might be the first class, but we are here until 4:50. All right? So, it is important that you come to class. All right? If you want to pass, come to class. All right? Some of you may be aware that both this class and Java have notoriously high failure rates. This is true and somewhat inevitable. The Python course doesn't really get into enough programming to really kind of test your mettle, right? This is going to be the first time that you are presented with real programming challenge, right? Some people, it is unfortunate to say, but some people are figuring out whether they want to do this for a living, right? And my position is, you know, this is a good test to tell you if you're cut out for this type of work, right? I'm not trying to be mean about it or anything, right? It's just kind of the simple facts on the ground. That being said, I'm absolutely happy to help everybody in every respect that I possibly can. There's just kind of like, there's a certain type of like way of thinking that you have to absorb in order to work with computers in this way. Yes?
This might be a bit of a weird question, but when it comes to like tests or like exams and stuff like that, will we be doing it in Respondus lockdown browser, or will we be allowed an IDE?
You will be doing neither. You will be doing them on pen and paper. Yeah. Sorry, but no. I have heard stories about all of the online testing that would make your hair curl. So no, I do not consider online testing to be secure. Period.
Okay, good.
Yeah.
I was going to say, I think it had last semester was a bit of a wild ride with this whole lockdown stuff.
Yeah. I mean,
I like just about most of my classes.
oh man, I had one guy, right, a student of mine last semester, who happens to be a Linux guy, you know. A thing you'll learn about me very quickly. In fact, right now, I am also a Linux guy. You may not be surprised. He's a Linux guy, and he was trying to run Respondus on Linux, and he tried to run Respondus through a compatibility layer called Wine, and Respondus itself sent like a nasty email to his professor saying this guy cheated. He was using cheating software, which it wasn't at all. He was just using Linux, right? And the guy just about got nailed for an academic integrity thing over it. But fortunately, I was able to swoop in and save the day and explain that Linux is Linux. Yeah, online testing is a bad idea, terrible idea. Pencil and paper, that is what we do. Yes?
And just to make sure, you're not expecting us to write code on pencil and paper. It's more so like,
I am certainly expecting you to write code on pencil and paper tests. So study up.
oh boy.
Yep, this is Java now. All right? This is not Python. This is Java. Now, that being said, you know, this is a little early in the semester for this discussion, but since it's come up, I am aware that it's not as easy to write out code on a piece of paper as it is with the assistance of your IDE. There are certain things that are taken into consideration when I grade code on a test, right? I am not really that concerned if you're making small syntax errors. Missing semicolons, missing braces, things of this nature, I'm not going to be taking marks off for, because it's the type of thing that's quickly and easily identified if you actually went to compile the thing. I'm more interested in conceptual errors, right? Are you using things according to the wrong data type, right? Are you applying the wrong operations to the wrong data? Your grade is basically how much work would it be if I took your code and I put it into a compiler? How much work would need to be done on it in order for it to do what it was supposed to do? That's proportional to that, basically, is your grade on the question. All right? Yes, because you actually do need to know how to code, right? It needs to be lodged in the gray matter, right? If all that you are capable of doing is regurgitating chat output, then you're not employable anyways, right? There needs to be something something in that cavernous space between the ears, right? So, pen and paper testing. That's what we do here. Question?
Just saying those words like you aren't going to take marks off, like syntax errors, already was like, okay, this is going to be way better than last semester because one of the teachers I had was a pretty big perfectionist.
Well, I mean, you know, mileage may vary according to the instructor. To be honest, like when I was teaching at the university, I would run tests for Python using a system called Jupyter Notebooks, it allows you to embed Python code inside of a document. Like you could have like question and then a box that you could execute code in, type thing. Here's the thing, right? When you have a programming IDE in front of you during a test, you're kind of at the mercy of the compiler. You know, like the amount of time that it takes you to fix a small bug is actually unbounded. And it can be extremely difficult to write a test in a limited amount of time because, like, if it doesn't compile, what's it worth, right? In that case, I was like using software to grade the work as well. And, you know, if it doesn't compile, what's it worth? Nothing, right? So, because when you're writing code on paper, you can kind of skip over your own syntax errors without having to worry about, you know, your progress being halted by a list of errors that you then have to go fix. You can actually, you know, you can do better on a handwritten test than on one where you have to satisfy a compiler. I'm not as difficult to satisfy on a written test as a compiler is, right? Does that make sense? Don't worry, we've got 3 tests. There's going to be the 2 tests and the exam. We're going to have a bit of a slope into it. We're not going to crush you immediately, all right? Yes.
How long do we usually have on tests?
The tests will be 2 hours and the exam is 3. And, you know, like, this is a course that has been running in this manner for a large number of years, you know. There is a sort of well-established Java test tradition. We are aware of what normally can be accomplished by students in your position in 2 hours. We tailor the tests around that. We didn't just start doing this semester, right? So I know it's a little like trust the process, but trust the process. Okay? Any other questions? Yes.
Is there a textbook in the class?
There is, but don't buy it. The notes you'll find are full of additional readings. If you really want to get into the stuff beyond what we teach, but beyond what we read in class or what we're doing in class, honestly, W3 Schools is a very good resource, which isn't the textbook. The textbook's like $100. I could recommend other textbooks as well. Actually, the textbook that is the official textbook for this class isn't even the one I would recommend. Let me show you the one I would recommend. I'm a big fan of the Rhinework computing series. On Java. There we go. There you go. That is the one that I would, for professionals, might be a little bit above your level for now, but by the end of the course, certainly this should be a good desk reference for all of you. Yeah, so it is my belief that given how so much internet content is now generated by the infernal chatbot, and how all of the chatbot introduces errors, and the chatbot is now ingesting its own errors to produce its own output. The quality of online articles and aids will degrade over time. I have seen it degrade in the last year quite considerably. I think that what is happening is the internet is now getting pretty close to being dead. If you want reliable information, you will need to pay for it. That's what I believe will be true. I think that's true today, and I certainly think that will be true 5 years from now. Absolutely. There are a few different things, you have to be very picky about what you trust. The official documentation of any particular language can be trusted. Textbooks are written by one person who had an editor who knew what they were talking about, but random internet articles are not what they once were in terms of being able to help you through this type of thing, right? Now, this becomes increasingly problematic as you start talking about code which has security requirements, but I'm going to shelve that discussion until all of you make it through to third semester and you're taking server-side programming, okay? So, that's a textbook. I would recommend that one. I'm not paid by them or anything. Just an enthusiast. So, good. Anybody in the room not able to find the room today? Yeah? No? Okay. All right. Well, if you couldn't find the room today, I hope you do better next week. So, let's talk about the part you've all been waiting for. How is your grade calculated? Oh, that white spot is just, oh. All right, there we go. It's a little small for you poor people sitting at the back of the room. There we go. All right. So, grade schemes. You don't have to tell me which one you want. I will assume you want the maximum of the two. All right? In both cases, your assignments are worth 30% of your final grade. There are 6 assignments, so quick maths, how much are they worth each? Very good, 5% each. Under the first scheme, you've got test 1 and test 2, both worth 15% of your final grade. Final exam worth 40% of your final grade. Under the second scheme, both tests are wiped out and that percentage added to the final exam. I sometimes call this the redemption arc. So if you really kind of flub it on the tests, but you pull your socks up and you study like there's no tomorrow, pull out a decent grade on your final exam. If that compensates for the tests, like if that's significantly higher than you would have gotten otherwise, we'll take your exam mark as being representative of your test marks as well. All right? But I want everybody to promise me that they will still come to class, that they will write those 2 tests, and they will not show up to the final exam imagining that they can pass on having only written the final exam. All right? Solemn promise? Very good. Pinky swear? Pinky swear. Okay, good. Because, like, as strategies for passing this class go, that's a very bad one. I always say that the best preparation for the exam is the course, right? If you come to class, if you participate in the stuff that we do in class, if you ask questions, if you have questions, if you learn, you have a much better shot at the exam than if you don't, right? I know that I'm recording the lectures, but that's not a reason to not come to class, all right? That is a very small bandwidth, right? This is maximum bandwidth. Also, if you were excited about that, you'll probably be a lot less excited about it once you hear the audio quality. It's really bad. But you know, I always say, if you want full-scale audio, it's available in the room. You know. But yeah. Any questions so far? You guys are a questiony bunch, so yes.
Are you gonna go over when the tests are?
Oh, yeah, I actually, we have an itinerary. Yeah, let's jump to that. So, let's just go through the weeks. So here's your weekly content broken down by week. So, week 1, that's this week. Introduction, IPO, input, processing, output, forms. So basically, we are examining how to take input from console, how to produce output to console, and we're not going to be doing too much in the way of control structures. Control structures are next week, right? So we're going to be doing if statements, switch cases, nesting things, loops, all of that stuff. Variable scope. We're not doing animations, don't worry about it. I missed it because it's behind that stupid white bar. So a thing that we're going to be using throughout the term is a library called JavaFX. It is an engine for producing pretty pictures in Java. You can like draw rectangles and circles and stuff. And that's going to be one of the things that we sort of use to illustrate various things as we go through the course. We'll be introducing that this week. Okay? It's not too bad. There's a template. Okay? Good. So, by week 3, we will be into object-oriented programming. So this is object-oriented programming, the course. Week 1 and 2 are preliminary intro information. They should be mostly review from intro programming. New material starts in week 3, basically. We will be discussing what are classes, what are objects, how do we document them, how do we construct them. Week 4, more of the same. We start getting into relationships between classes. Week 5, it says review test 1. We're going to have the test on Friday. The Thursday class will be a review session for the test the following day. Okay? Sound good? Good. Week 6, the week after the test, we will be discussing data structures, arrays, just arrays of objects as well, just arrays as a topic. You guys did a little bit of this in Intro Python, right? You guys did lists or something? Yeah? Same basic idea, but we're going to be a bit more rigorous about it because Java is a much more rigorous language. We will then have a week on GUI, so we're going to dip back into the JavaFX stuff fairly heavily. We'll learn how to create buttons and take text fields and all of the stuff that JavaScript does easily, we will do painfully in Java. After that, we start getting into the real conceptual work in the class, which is inheritance. Do you have a question? No? Okay. Inheritance is probably the most difficult topic in the course, and we spend, week 8 and 9 are kind of exploring different angles of the same thing in that respect. Polymorphism, yeah. After that, in week 10, we will have test 2. After test 2, week 11, exception handling, lists, and mouse events. After that, lists, the ArrayList API, more data structures. The final week is dedicated exclusively to review, and then the final exam will be during exam week. Make sense? Any questions? I will publish specific dates for the midterms as soon as I remember to do that when I'm at my desk. I have the dates though. So when considering this schedule, reading week is not a numbered week in this schedule. So wherever it falls, you just, insert a week there. Okay? Good. Any questions? Yes, sir.
Sorry, so no midterm, it's just the 2 tests? Or there is a midterm?
So when there's one test and it's in the middle of the term, it's defined as the midterm.
Okay.
We have 2 tests and a final exam, so no midterm in addition to that.
Oh, I see, okay.
6 assignments, 2 tests, 1 exam, that's it. Yeah. JavaScript has a midterm though. But that's because it only has 1 test, and it's in the middle, so it's a midterm test, or a midterm exam. But the tests are cumulative, right? So the test 2 material tests all of that, all right? But this is somewhat inevitable because the material that we will be talking about is highly constructive anyway. right? In week 3, we're going to be defining what an object is. For the rest of the course, we're going to be exploring different things about objects. You can't have forgotten how to define an object when you're using it for other purposes. Right? Make sense? So, good. That's kind of just the nature of the material. It's like saying, oh, we don't, I'm not going to put any if statements on the final exam because we already covered those in test 1. It's like, well, I mean, there might not be a question that's specifically like, write an if statement, but if you think you're off the hook for if statements, good luck. So, all right, which apparently you guys have done to death, so that's good. Good. Yes. Programming environment, we'll be talking about that. That's the textbook, don't buy it. Aha! So we're going to be doing a slightly new process. They piloted this last semester and it had pretty good results. Code review. So when you do one of your assignments for this class, 40% of your assignment grade will be an in-class code review. How this works, I will assign an assignment. The next week on the Friday, we will take some class time, not the whole class, some class time. Everyone will load up what they've got so far, not a final submission, but what you have so far on your computers. I will come around and take a look, and I will give you a grade out of 4 according to how much effort you've put in so far. But most particularly, whether it looks like you AI generated the whole thing. Right? Yes?
Well, just know, sir, generative AI is it's kind of, well, you all to say it's basically dead to me. So
Good! Yes!
I've made myself like a little oath to never use generative AI for stuff ever. Not even just school, just stuff ever.
Yeah. So I must of course now comment on generative AI in a general sense. So here's the thing. This is a school, and I'm giving you school assignments. School assignments are small, necessarily. I can't give you a year-long project for an assignment. At best, that's your capstone, right? Because of the simplicity and scale of the work that we need you to do, these assignments are trivially solvable by the chat algorithm. This is a fact, right? If you don't do your own work, you will not learn, right? If you get the chat algorithm to generate the stuff for you, you won't learn, right? And this includes, oh, I just wanted a solution to look at so that I could, I'm working on my own, I just wanted the solution to look at, right? That's also bad and wrong, and you shouldn't do it, right? You gotta, it's gonna be work, right? There are gonna be times this semester and next semester and the semester after that when you will rue the day you ever heard of this program, right? Oh, programming. Oh, that compiler. You have to struggle in order to learn, though, right? When I code on the board, I make things look easy, right? I've been coding for like 20 years, right? I'm actually a little older than I look. So, over the 20 years that I've been coding, the number of hours that I have spent staring at the screen, not knowing what the problem is, it's a lot, right? I wasn't born a coder, right? I had to struggle to achieve the level of perfection, whatever level of perfection that is, that I may display. I am far from being a perfect coder myself. But if you take the shortcut and you don't throw yourself into the meat grinder, you're not going to have the experience, which means you're not going to be any good at it. And when it comes to the test, you're going to fail the test. Period. Right? That's just true, right? So the thing's not your friend, right? Computers in general are not your friend, right? Like, it's a mistake to imagine that a computer is your friend, right? But the chatbot itself, it's not just not your friend, right? It's actively trying to sabotage you, right? So, please don't. Please don't. We're going to have code reviews. You're going to have to bring your code in for me to look at it before you submit it. I'll know if you've been generating it. And if you've been generating it, I'll say, don't submit that. That's garbage, right? That is AI slop, right? And trust me, I've been doing this long enough that I know, all right? I know it when I see it, yes.
Code reviews will always be on Fridays?
Yes, yeah. And of course, attendance is necessarily mandatory if you want the marks for the code review, on code review days. Yeah, I mean, I'm not gonna let you like Skype in or whatever. Oh man, Skype in, that dates me, doesn't it? Oof! That's okay. So, yeah, it's not like I'm not going to give you an oral examination, right? All it is, open your code up, I'll take a quick look through it, I might point to one thing and say, explain what you did here, and basically you just have to satisfy me that you're doing your own work. That's what the purpose of the code review is. Okay? It does require you to have started the assignment before the code review though. Okay? We had a certain degree of success with this last semester, so we're rolling this out a little bit more. I'm not currently doing this in JavaScript, but if I'm I'm testing it on you guys. If it goes well, maybe I'll roll it out in JavaScript too. Yeah. Good. Oh no, that's the wrong late assignments policy. Oops. Here we go. See, this was updated after after the blueprint was updated, but I was a good egg and I imported my blueprint before it was necessarily ready. Okay, let's see here. Where is it? Tests. Late assignments. Here we go. Late penalty of 0.5% per hour, period. If it's more than 50%, I won't grade it. That's the policy. Yeah, you're working on time. Okay? 0.5% per hour, the intention behind that is if you're submitting 5 minutes past midnight type thing, you lose a little bit instead of a 20% chunk or a 10% chunk, right? That's also something we're trying out this semester. But yeah, Any questions? Assignment due dates will be Sundays at midnight. So you get the weekend to work on it. But please don't expect me to answer rapidly to emails over the weekend. If you, if you have questions, please get those in by Friday. Okay? Sound good? Is that everything with the syllabus? I think that's everything. Any questions in general? Philosophical questions? No? Okay. Not yet, anyway. All right. So, let's get into it. So, let's talk about the required software. In this class, the programming IDE, which you use, well, the one I'll be teaching is IntelliJ. JetBrains. I always confuse NetBeans with JetBrains, but it's JetBrains IntelliJ, which is actually quite a popular one. Before we get into it, here I'll show you some statistics. I'll show you why Java, why now, why is this, why on earth? So you guys know what Stack Exchange is? Anybody know what Stack Exchange is? It's the website that the AI crawls for all of the answers to all of your coding questions. So Stack Exchange, it's fun. It's a little bit like Reddit. You kind of post a question and then people post answers and they're upvoted or downvoted based on whether other people think they're good or not, right? One of those types of things. But it's basically Reddit if it was run by ultra nerds, because they're only answering like highly technical questions about like programming languages and stuff. It's actually extremely useful, and Stack Exchange or Stack Overflow, pardon me. Stack Overflow is the one. Stack Exchange is like a similar thing, but different. Anyway, Stack Overflow is like one of those sites you can trust. The only problem is it gets difficult to read the answers because the answers are written in a highly technical fashion by highly technical people. But if you can read it, you'll get a good answer most of the time out of Stack Overflow. So every year Stack Overflow does a survey of all of the contributors to see trends in technology, right? So this is the survey, these are the survey results from last year. Very interesting data. So you guys want to see what the most popular programming languages are? There you go. Oh, yeah. The light is going way over time, isn't it? So, the top programming language also happens to be the worst. JavaScript. It's terrible. It's like, you guys have JavaScript with me, don't worry. We will have plenty of time to explore how terrible JavaScript is. JavaScript is so terrible that an entire new language was invented to try to make it less terrible. You guys know what that language is?
Can I just take a guess?
Yeah.
Is it TypeScript?
It's TypeScript, that's right. So here's the thing, right? These two are not actually competitive, right? TypeScript compiles to JavaScript. So in fact, the popularity of TypeScript is limited by the popularity of JavaScript. What this implies is that 2/3 of everybody who's a real developer develops in TypeScript and then compiles to JavaScript. 2/3, right? Not a programming language, not a programming language. Python, sure, okay, Python. Bash, which you should all learn. Bash is very useful. I am a Linux person, of course, so maybe I'm a little biased, but Bash is very good and important. TypeScript and Java. So Java is the second highest, general purpose programming language on that list. So yeah, Java is industry relevant. Even though it feels clunky and old and everybody makes jokes about Java being dead, it's not. Okay? Database, don't worry about that. This one I just want to highlight. Docker is really cool and important, and you should learn it. I won't say anything more. I can't. I have to keep moving. Web frameworks. Node.js is the top one there. React is a front-end framework, so it's not competitive with Node.js. But this isn't a web class, this is Java. Dev IDEs. That's the one we're going to be using in class. Okay? It's pretty, it's pretty high up that list. I know, that's funny, right? I mean, that is kind of monstrous. The only reason that that's the case is because Microsoft bought GitHub and then shut down Atom. When Microsoft bought GitHub, all the GitHub people were like, "You're not going to shut down Atom, my favorite IDE, are you?" And they're like, "Of course not." And then 2 years later, what do you think happens? There was a question somewhere? Yes?
Yeah, why not use Visual Studio Code?
This one, IntelliJ, is made specifically for Java, and it's at best in VS Code, you're going to be installing a whole bunch of Java extensions. That set of Java extensions is not better than IntelliJ, right? This one also because it's a general purpose tool, it also weights pretty heavily in this graph, right? This is pretty impressive because the only thing it does is Java. Well, Java and Kotlin, right? Question?
So just straight up, the people who use that software, they pulled the plug on it, right? If you guys made it, they essentially pulled the plug.
Oh, no, they got bought out by Microsoft, and Microsoft shut them down.
Yep.
Yeah.
Good old Microsoft.
Good old Microsoft.
Really just went up to the people, bought them, and then just to the people using that program,
Yeah.
they just basically just trust us.
They-
We promise we'll take good care of your little program.
They
We
bought out their main
promise.
competitor and shut them down. Yes, that's what they did.
To be fair, it wouldn't be the first blunder Microsoft did, or the last.
Well, I'm a Linux guy, so of course Microsoft is evil. Microsoft is evil. That's just
And
it.
it's not just from that perspective, look at the gaming perspective as well.
Oh, man. Yeah, don't even get me started, man. Don't even start Microsoft. So in order to get IntelliJ, first of all, you can get it through these computers. It should be natively installed. Let's check. Yep, IntelliJ right there. All right. So on lab computers, it's installed natively. You don't even have to go through Mohawk apps. All right. However, on your own personal computers, which I recommend you put it on your own personal computers, this document will go through how to do that. I'll give you, there are a couple of talking points that I have here which I'd like to go through as well. All right, let's talk about Java. Let's talk about programming languages and let's talk about Java. All right? Where's my clicker? The Zapper stupid thing always runs away. Actually though, where is it? Oh, I put my code over it, of course. Boop. There we go. Obey. There we go. nice soft programmer lighting. So, it's not even my marker. So, programs. What is a program?
A list of commands that does a thing.
A list of commands that does a thing. Very good. Often encoding an algorithm. When we write programs in computers, they are text encoded. So they're files. A program is a file. A software process converts that file into executable code. However, not all of these software processes operate the same way. There are two main categories: compilers and interpreters. All right? Does anybody know the difference between a compiler and an interpreter? Also accepting guesses.
I think the interpreter is the one that converts the language from like what we read to actual computer readable code.
Well, compilers do that as well. That's the purpose of both of these categories of program. So this is the difference, right? With a compiler, you take programming source code and you convert it all at once in one go into executable code. You then have, as your output, another file which is executable code, which you can then execute. A program, a compiled program. An interpreter takes your programming code and feeds that into the software process, directly computing the instructions without producing an executable file. Right? Now here's a question. Is Python a compiled language or an interpreted language?
I believe it's a compiled language. No.
Not generally. You can produce Python executables, but what these really, it's kind of sneaky. All they're doing is packaging up the Python interpreter environment with the source code, right? So, let's say for compiled languages, we have the following workflow. Imagine that this is your operating system, all right? We have a file, and your sort of typical example of a compiled language is C or C++. I used to teach C at the university, so I refer to it a lot. It's one of my favorite languages, actually. Your C file, right? You take this file and you feed it into a process that's running on the operating system, the compiler. In the case of C, one of the better ones is called GCC, the GNU Compiler Collection. The output of this program is a file. Let's call this a.c. A.exe for all of you Windows people out there, and just A if you're in an enlightened operating system. You then take this file and you operate it, you execute it directly on the operating system. So you take this file and you execute it in the same manner that you executed the compiler itself, a.exe. This then produces, whatever your output is. Let's say that output is a smiley face on the screen. Output. Make sense? The program takes input from a keyboard, produces output. It's a program. That's a compiler. Make sense? Any questions? Now, let's consider interpreters. Typical example of this would be, of course, Python. Although JavaScript is also an interpreted language when we get there. Because I'm pretty sure you should all be in like my Tuesday section for JavaScript next week, yeah? Yeah. Because they do it like by block scheduling, so. Unless you're like repeating the course or something. But yeah, anyway. Interpreter. We have our Python file. We launch the Python interpreter. But rather than producing an executable file, we plug it into the top like it's a video game cartridge. It takes your input and it produces your output. Right? All of the talking that it does to the operating system occurs through the interpreter. Does that make sense? So the reason that this is a good system for JavaScript is because it actually doesn't matter how many layers you put here. You can actually like layer this in like Chrome. The interpreter is sitting on Chrome and the program is sitting on the interpreter. That's kind of how it works in JavaScript. Make sense? There are advantages and disadvantages. Can anybody think what some of the advantages and disadvantages are? Knowledge of the trade-offs between different technologies is it's an important area of knowledge for you to have as professionals in the field. Yes?
If your program gets longer with an interpreter, it might take up more compute.
What do you mean by take up more compute?
The thing that I'm imagining is because it's running directly like through the interpreter, because you need the interpreter to be there, it might take up like more resources in order to run that interpreter with your program.
That is correct. 100% correct, actually. You require far more operating system resources, memory, everything, to run an interpreted program versus a directly compiled program. As a result of this, compiled programs tend to be much faster, right? So speed as well, not just memory usage, although the two are often correlated, right? So, compiled languages tend to be fast. Interpreted languages, what's the advantage to that? I'll just tell you. This thing can run dynamic checks, right? So the interpreter can run checks on the program as the program is running, as opposed to a compiler, which must perform all of its checks up front. Does that make sense? So far, so good? So, all right. Anybody care to take a guess about Java? Is Java compiled, or is it interpreted?
I'm going to take a guess and say compiled.
You're right. Any other guesses?
Compiled.
Compiled?
Interpreted.
Also correct. Java is a language which is both compiled and interpreted. So, let me show you how this works. It's a little bit of a special little guy. Let's call this, just to be consistent, a.java. So, Java has two processes, right? The first stage is called Javac. Javac, the Java compiler, right? Performs all kinds of static checks. But, here's the difference, does not produce directly executable code, as is the case over here. What it produces is a class file. So we have a new file format, a.class, which is post-compilation Java code. This class file is then interpreted by Java. And then it does input and produces output. So it does both. Does that make sense? I mean, mechanically, is it clear what it's doing? Not really? Perhaps I could explain like why would they do this way, right? So it's important to understand like where Java sits historically. Whoa, okay, I can't sit on that. Oh my goodness. Whoa, all right. I'll sit on this one. There we go. That'll work. So, let me pull you back to the late 1980s, all right? Pretty much all languages at this point are compiled, right? Compilation is an established thing. We don't want anything that's not compiled. Please just, let's respect tradition, right? Then Java's like, well, interpretation is kind of a thing, and computers are becoming a lot more powerful, so maybe we could get away with it. But, people are going to get mad at us if it isn't a compiled language, so both. And so they did. Now, this turned out to be a great move, and it's the reason that Java is still as popular as it, it remains popular to this day, despite the fact that Microsoft came up with C# to try to knock it off its pedestal. It largely failed. Here's a quick tip about programming languages, right? Whenever you try to write a new language that replaces all other older other languages, all you end up with is a new language, in addition to all of the rest of them. Programming languages don't die, all right? So what happened, and this is how they had to advertise it, right? They called it the Java Virtual Machine. That's what the interpreter was called. So the Java Virtual Machine had the advantage that you could write a virtual machine for many different types of hardware, but if you plugged a Java file into the compiler and compiled a class file, that could be the same source code no matter where it was running. This is something that we take for granted today, right? But back in the, historically speaking, you used to have to write a program that was specific to the machine it was running on. Imagine that for a moment, right? Like, imagine if you had to write a different program. You had to write actual different source code for every kind of phone there is out there, right? Is that a manageable situation?
No.
Not even slightly, right? So, the Java Virtual Machine allowed one common copy of the source code to be run on many, many, many different types of architecture. C did something similar as well, actually, and as a result of that, became very popular. It also introduced a lot of what at the time were cutting-edge mathematics in programming language construction, and that's actually what we're going to be studying in the course. All of this object-oriented stuff and polymorphic types. This was like new and interesting material back in the like the math had been developed in the 70s, and it took about a decade for it to find its way into programming languages, right? So the JVM was very popular. People were like, ooh, interpreters are very cool. Maybe we could put these in the internet. And that was the idea that resulted in JavaScript. But Java and JavaScript are not similar languages, not in the slightest. So the saying goes that Java is to JavaScript as car is to carpet. As a matter of fact, the only reason that JavaScript is called JavaScript at all is as a marketing exercise. They were trying to piggyback on the popularity of Java. It actually is completely an independent, like it was made completely independently. It's kind of like, you know the polka dots, like the fabric pattern polka dot? You ever wonder why it's called polka dot? It's basically the same reason. Polka dances were very popular at the time someone was trying to market this particular type of fabric, so they called it polka dot. The dots don't have anything to do with polka, but that's, you know, it's a marketing exercise, basically. Does that make sense? So that's Java. So let us come then to the manner in which Java is distributed. So Java, when you go to download it, and you know, I'm telling you this because you can't claim to know how to program Java without knowing this. This is, you know, bare bones facts about the language, right? Whenever you go to download Java, there are two files that you will be presented with, and you might be saying to yourself, I don't know which one of these I need to download actually, right? There is the Java Runtime Environment, JRE. Any classic Minecraft players out there? Yeah? You know, you had to get the Java Runtime Environment back in the old days, right? Back before they, you know, if you're still running the Minecraft Java edition, that's the case, right? Which Microsoft again is trying to kill because they're evil. That's the Java Runtime Environment, right? The Java Runtime Environment is this much. Well, actually, it doesn't include the class file. You provide that. JR, Java Runtime Environment. The other thing you have is the Standard Development Kit, SDK. The Java SDK, includes both the compiler and the runtime environment, the virtual machine. So, because we are developers who are developing software, that's the one you want. You might already have, in fact, you probably already have on your computer the Java runtime environment. Your computer probably already has Java. But if it's not the standard development kit, you don't have the compiler, so you cannot write Java, compile it, and execute it. Does that make sense? All good? Any questions? Okay. Yeah, so that's Java. Yeah. The instructions here. Oh, let me just turn this back on. So, I'm just going to go through this and give you some of the important pitfalls. Have this document open when you're installing it on your own computer, right? Pitfall number one: when you're selecting which Java development kit to get the full Java development kit, because this includes the JavaFX libraries that we will need. If you don't get that one, you won't be able to do the first assignment. Okay? So get the full version, not the standard or the light version. Okay? Verify it, yes. Good. Install IntelliJ. Very good. It goes through that. Run the installer with the defaults. And at some point you may have to select which Java SDK you installed and select which one it wants to use. It should auto-configure, but that might be, you might have to specify. If that's the case, just select, it'll say Liberica, and that'll be the one. Okay? All right. Shall we open the software now that I've been banging on about it for like half an hour? Launch IntelliJ Community Edition. There we go. Welcome to the splash screen. See? See Duke right there? He's a mascot. AI got his arm color wrong, but you know, whatever. So, to start programming, you need to create a project. There we go. Create a project. Generally speaking, if you create like one project for every week of classes, that's probably good. Be careful about storing things on these local hard drives. They're occasionally wiped. Certainly, I don't recommend doing any assignment work on them and leaving files. You know, put it on a USB thing. Okay, take it with you. So, yeah, we're not going to do like a new project for every piece of code that we write. Okay. So, let's call this, oh, and if you're not currently actually doing this, actually do this. Log into your computers and open it up, please, right now. You guys have it open? I'm gonna look. Ha! You'd have thought I was stuck at the front of the room, eh? Alright, you got it open, good. Come on, everybody, yeah. Oh yes, dark mode, yes. I think the correct theme is called Darkula.
It is Darkula.
Yeah. Yes. Good. New project. Call this Baby's First Java.
I can't read the name though. What is it?
Baby's First Java.
Yeah.
Oh, no, the application name.
Oh, it's IntelliJ.
Right.
If you just toolbar INT, you should get it.
I'm not getting it.
Oh, really?
Wait, is this it? IntelliJ idea community. Yes.
That's it.
That's it. Alright.
Alright, there we go. There we go. You can add sample code if you want, but don't.
Baby's First Java, you said?
Baby's First Java. That's right. Because, oh, you guys, you haven't done any Java yet. You're so cute. So, ooh, can I increase the size on that, please? Just a little bit. Oh, man. What's the, oh, man. Forget the view.
What do we make the JDK?
Liberica.
Alright.
Yeah.
Anything in advanced settings or no?
Nope, not in the least. So, to create a new Java class, if you didn't have it include the example code, source folder in the project pane, right there, right click, oop, there we go, new Java class.
Where's the source for the example code?
It's like a checkbox on the splash screen. If you click that checkbox, you don't have to do this, but otherwise, just don't worry about it. Right click on the source folder, create new Java class. You'll be presented with this pane. Don't worry about these. We'll have talked about at least one of those by the end of the class, by the end of the course. We shall call it,
So I go new Java class?
yes,
Alright.
let's call it hello.
Hello world.
Yeah, well, just hello. So,
Enter?
when creating a Java class, the convention is that class names are capitalized. Variables are lowercase, class names are capitalized. Now, you guys remember what hello world was in Python?
Print hello world, well, brackets, and then the,
Double quotations?
yeah, double quotations and then hello world.
We're already up to more characters than that, eh?
Yeah.
Well, just watch this, my friends. Public static void main string array args system.out.println hello world. Some of you will have already seen this because you had the you auto-generated the thing. This is what it dumps in for you. Okay. But how do I run it? Well, you'll notice once we added public static void main, we got a little play arrow on the class. It's hard to see here, but hopefully you guys see it on your own screens. That means that that is now an executable class. So, if you right-click on it, there we go, run hello.main. Takes a moment, and there's your hello world. Ta-da! You have to tell it what class you want to run.
What button is it?
Open up the source folder, find the file, right-click, run hello.main. Yes.
I'm getting an error saying Java class hello is public.
I got an error too.
Hmm.
Oh wait, I know why. Silly me. Got something. Semicolon.
Oh.
There we go.
Where'd you put the semicolon?
You put it at the end of the round bracket.
Yeah, I have that. It's still giving the error. Should be
Hold on,
in,
let me see. I might be able to fix it.
should be in the file.
Let's see what your R.
Let me see what you got here.
Well, what is it called then?
Oh, you forgot something.
I just,
Hmm.
I didn't
Very
exactly.
strange.
Might be the indenting. That might be the problem.
No, that's not the invent. That's not the problem. Strange. Try making a new file.
Just in here.
No, in source. Interesting. It might. Maybe it's a problem with the project. Play with it a bit, see if you can get it working. If not, I'll come back. Anybody else having extraordinary problems? Did everybody get it working? You have a problem?
No, I got it.
You got it working? Awesome. That's because string needs to be covered.
And that can work.
Nice.
That should take away the public.
Oh.
Yeah,
If you
that
make
happened
class
to me
below.
too.
Oh, interesting.
Sometimes when you public it, it just won't register it as a class for some reason.
Odd that we have a difference in this respect. Oh well. It's not actually necessary. So, not at this stage. Let's see. Do I have a difference when that happens? So once you've run it once from this menu, you can hit that button on the top there. Yeah, weird. Strange. Oh well. What? did you just download that to your own laptop? Is it like, is this happening on people's own laptops?
I've had IntelliJ on my laptop for a while.
Oh,
I just haven't used it. I downloaded the JDK you told us to download.
maybe it's like a version issue? I don't know. But it seems like it works if we take away public, so we're all good. Question?
I'm gonna try to remove this and see if it works. It's giving me an error with the print in.
Oh, that's because that's line, LN, not IN.
No, it is print in. That is an I.
Yes, it needs to be an L,
Oh.
lowercase l. Yes. Good. All right. Seems like we got through Hello World. So, good job, guys.
We did it. Only took-
You're all Java programmers.
I'm gonna apply for Pinterest.
I'm gonna get the next Minecraft update.
I mean, yeah. This is probably about as far as you got in intro programming, right?
Yeah, basically. With how long that course took?
Oh yeah.
So, let's do a little bit of forensics now that we have a working program in front of us. All right? Because it is important that you understand what is in front of you. All right? Start at the top. Class hello. Java is an object-oriented language, so everything in it is an object. Objects are instances of classes. So, in order for it to be anything in Java at all, it needs to be in a class. That's how Java operates. There's nothing that's not in a class. All right? Obviously, it gets more complicated from that. Question?
I was just gonna ask, does it basically just work like how functions do in Python?
Not quite. So, a class is a collection of functions. We call them methods when they're inside of a class, right? Some languages have different terminology. In Java, we call them methods, right? It's a collection of methods plus a collection of data, variables. Take those up, package them together, and you have a class. Does that make sense?
Sort of.
Yeah. For this, my friend, is a method. The class may contain many methods. So, we will properly dig into classes in week 3, but for now, warning, this language contains classes, all right? Incidentally, this is also the case in Python. The only thing is that it implicitly wraps everything in your file inside of class main for you. It hides it so that you don't see it. But it's still doing that. You can actually expose that in Python by viewing what the class name is of classes you define inside of your program. It'll say it's like main.this, and it's like, what do you mean main.this? I didn't declare a main. No, that's the whole file. That's what it did for you, right? But anyway, so public static void main. What a mouthful, right? It is going to be the object of this class to gradually explain what those keywords mean, right? We're going to have a week where we talk about static. We're going to have a week where we talk about public. We'll talk about void pretty quickly. But this is your main function. In non-interpreted languages, execution normally starts with main, right? A programming source code may contain many functions, but the specific function that's the first one that you execute when you run the program is normally called main. And this is across many languages that this is the case, right? Java is no exception. Putting a main method in the class means this thing can be executed. Make sense? So far, so good. Void is a null data type. So it's the data type that means nothing, right? This is the return type of the function. Now, this will be a new concept for all of you folks who did functions in Python. In Python, you don't define a function with a return type, right? You just say, it's a function, right? In Java, in strictly typed Java land, you must know what the data type of the thing the function produces is. This is necessary. If you don't provide it, you will not be able to compile your program. Right? The same thing is going to be true of variables. When you declare a variable, you must do so with a data type. You are not permitted to violate that data type. That is a contract between you and the compiler, right? Java is a strictly typed language. You're not allowed to be like, oh, well, you know, on line 7 it's an integer, but, you know, I feel it should be a string on line 13, so let's just assign it a string. That works, right? Not in Java. All right? Java's like, no, I have a type checker, and you must satisfy my type checker. So yeah, so basically void here means that main doesn't return anything, which, you know, is fine. It's main program execution, it perhaps shouldn't return anything. So, this is the argument to the function. String array arguments. This is where it takes command line parameters, which is not really something we have to worry about in this class. It's something that comes into it once you start doing things like bash scripting. But basically, for our purposes here and now, that's a big old don't worry about it, not your problem zone. All right? So, curly braces. You guys, how many people have worked in a language that has curly braces? Okay, you guys have worked in other languages then. What languages you guys worked in?
Arduino.
Arduino. Arduino isn't a language, it's a microprocessor.
It's C++. Yeah.
C++? Okay. All right, you impress me. C++ is a difficult language. Yes?
Java, C++, and C#.
All right, so you're like, okay, I got this. Anybody use C before? No?
Oh, yes.
C? Oh yeah, you said C, yeah. Any JavaScript in the room? Yeah. Lua? Any game modders will have used Lua, yeah. Anything I'm missing?
Python, I guess.
Python, I guess, yeah. I mean, yeah. I kind of, like, I often tell students that if anybody claims to know Python after having taken intro programming in Python, you claim to know Python on your resume, you're basically lying, you know? Well, I mean, like, if you were in an interview for Python, would you be able to hack it?
No.
There you go.
With what we learned, no.
Yeah, I mean, Python isn't a, like, I used to give Python a lot of stick, and then I started teaching JavaScript, which is a true story. But yeah, Python's not too bad. It's a good language to know. But the problem is, like, everybody and their monkey learns it for their first programming language. So, like, everyone claims to know Python, but very few people are actually, like, good Python programmers, right? Like, you know, the top end of Python is, like, it gets quite interesting towards, you know, towards the more advanced uses of it. But most people just use it for machine learning and AI stuff anyways, though. And by the way, there are languages that implement their own compiler and languages that don't. Python's interpreter is implemented in C. Just saying. Not throwing shade, I'm throwing a little shade. You know what C's compiler is written in? That's right, it's C. Boom. So, anyway. So this is the main method. The stuff in here executes, right? This is a code block. Anything between curly braces is a code block. The curly braces say this is in here, right? This statement is in this method. Make sense? So far so good? System.out.println. Again, a bit of a mouthful. System is an object that contains system-related functions, right? Out is the output stream for the program. It's contained in system. Println is a method of the output object, which is a sub-object of system. This is dot syntax, right? When you say, okay, I have this object, but I want to access something in it, you access that through dot syntax. And as we demonstrate here, you can chain dots, right? So system dot out dot println. Make sense?
Yes.
Good. It's a method. It takes an argument. In this case, it's a string. It can take a bunch of different things, right? And it says, take this string, pass that to the output stream, please. Standard output. And it does. So, you see what I mean when I say that Java, like, it's a verbose language, but it shows you everything it's doing? You know? Like, sure, that's a lot more complicated than print, but we understand far more about the structure of a Java program by picking apart its hello world than is true in any of these, any of these languages where it's just like print thing, you know. So, any questions? Yes.
What would happen if you were to remove void from there?
Good question. Well, it complains. Modifier static is not allowed here. So basically it thinks static is the return type now. So what if we get rid of that? Invalid method declaration, return type required. So you're not permitted to declare methods without a return type. A related question is, what if we change this to integer? Well, it complains you're not returning an integer, right? You're only allowed not to have a return statement if it's of data type void, return type void, right? So, what happens if we provide the requested return statement? Return 0. Main method must return a value of data type void in class hello. Please define it as follows. So, interesting error. We managed to push it from a compile time error to a runtime error. So the runtime environment says, no. Main has to return void. But that's coming to us from the Java virtual machine. We have satisfied the type checker. So it's correct from one perspective, but incorrect from another. There was a question over here. Let me just, you had a question?
No, I figured it out.
Okay, you have a question.
What if you take away string and args in the for brackets?
Well, let me just put this back to void first. Similar problem. Main method not found in class hello. Please define the main method as public static void main string args. So it's like, nope, I'm expecting a particular thing, and if you don't give it to me, I won't execute it. This is a very different flavor from Python, right? Python bends over backwards to try to take your junky, horrible code and run it anyways, right? Java is much more strict. But this also means that if the program runs, it's far more likely to be correct, right? That's the trade-off. Loose languages allow you to compile any old thing. But because they allow you to compile any old thing and run it, the likelihood that that thing is correct is lower. If there are all of these gates and hurdles that prevent the program from compiling unless it's met these requirements, you're excluding huge classes of errors that could occur by doing so. So the programs end up more correct overall when they've been put through a more strict compiler. Does that make sense? Yeah.
I just noticed that the S in a string is supposed to be capital. If we made it lowercase, would it still work?
No. In fact, no. It must be uppercase because that is the name of the string class. You can see that's red, that's an error, cannot resolve symbol string. So, we're kind of ranging a little bit, but this is fine. This is like, I like a first class that kind of like follows questions actually. So, this comes down to data types in Java, right? There are two categories. There are classes and there are primitives. Classes are capitalized, primitives are not. The string has methods in Java, right? It has things you can do on it. You can test the length of a string using a method, right? Because it contains methods, it's an object, right? Which means it's derived from a class, right? Something like integer, right? Just like this. int, right? These are just the integers, right? Like 3, -4, etc. These don't have methods, right? They're just numbers. So they're not classes. So they are lowercase. Does that make sense? Void is also in this category. That's why it's not capitalized over here. So again, it's a little bit strict, but it also means that when you're reading Java code, at a glance, you can tell whether something is a class or not. Right? Good. So, any other questions? All right. Let's see here. What am I actually supposed to be teaching you? That's a good question. I despise these things, these article style things. How do you teach from an article? Come on.
It's impossible.
Yeah. I mostly just ignore them. And I tell you what you need to know. Basically, this is how I teach. I just teach you, and then I check these to make sure I didn't miss anything. So yeah, the hello world. There you go. All right. Oh yeah, of course they want you to do that immediately. All right. Here's one of the ways that IntelliJ is a good editor, specifically for Java and something you want to use. Public static void main is a lot to type out. Try this. PVSM, tab, oh, come on. Public static void main, tab. There you go. Ah. There are a lot of little shortcuts for common Java patterns in this editor. Just moved on me. What the heck?
Oh, no,
think that, yeah, I felt it like, is this one of the motorized ones?
Oh, no, sir, you don't understand. It's a spooky ghost.
And I've been resting my briefcase on it this whole time. Oh, man. All right, so, what was I saying? Ah, yes, shortcuts, PVSM, or PSDM, pardon me. Okay. I'm going to skip threads for now. Come back to them. Comments. Comments are important. You must comment your code. Python's commenting is awful. Anybody remember the comment character in Python?
Hashtag?
Yes. Although, would you like to know what its actual name is?
Ampersand, isn't it? No, that's the star.
That's ampersand.
Yeah, that's the.
Octothorpe.
Octofork.
Octothorpe. Yes.
Yes, because why wouldn't I know that?
Right?
Basic knowledge.
You know what? I actually won a pub trivia by knowing that at one point. Yeah. So, Octothorpe. That's your comment character in Python. Here we use C-style comments. All right? Which means that // is your comment character. This is a comment. That is for a single line comment. The reason that Python sucks, one of the reasons that Python sucks, is it does not support multi-line comments.
Yeah, those.
The triple quotes doesn't quite count. Yeah, it does weird things. It's not quite the same thing, actually. Like, you can use it as a doc string. It actually interacts with the code. A true comment is stripped out of the source code completely before it's sent to the compiler by the preprocessor. This is not the case with the triple quotes in Python. But, yes, good, yes, I like the reposts. So, this is multi-line commenting in Java, and in all C-style commenting languages. /*, // anything between those is a comment. Sound good? That can be as big as you like.
So /n? Oh, so starts to comment and ends to comment.
Yes. In fact, it's very useful because you can do things like this. Comment a whole method very quickly and easily. Like a lot of editors will have a shortcut key for like commenting out like blocks of code using the comment characters, but they're always a pain in the butt. Like consistently, like single line comment characters are just not as good as multi-line comment characters because that's not what their job is. So, yes.
So you don't need to close a single line comment.
No.
Okay.
Correct. Now, yes.
If I remember, it looks similar to like a CSS class.
Yes, CSS I believe uses the same. This is also a comment. Now, here's the thing though, all right? In Java, in this class, we have very specific commenting standards, all right? There are certain things that you must do, pieces of code that you must provide comments for, or you don't get all your marks for comments on when I grade your assignment, all right? There is a system called Doxygen, all right? It applies to many different programming languages. Java is one of them. There are programs, if you do the comments a particular way, there are programs that will scrape the source code and produce like HTML-based documentation pages for your source code, right? That's useful, right? You can actually generate it right from IntelliJ, but you have to use the right kind of comments, right? The right kind of comments are multi-line comments which start with 2 asterisks, like that. That is the Java doc comment. All right, we'll explore that a little bit more. There are some more specific requirements, but it would be, I would be remiss if I didn't address that when I'm talking about the other types of comments. This is actually the one you'll be using the most of. All right, make sense?
Wait, is that the multi-line comment?
Both of these are multi-line comments. All right. Like if you consider like the syntactic requirements of the language itself, this asterisk is unnecessary, and so is that one. But when the Doxygen scanner goes through and scans for Java doc comments, it needs these to consider it a Java doc comment. Otherwise, it's just miscellaneous code documentation, and it won't scan it or pick it up. Question?
So would you start writing like documentation after line 7? So would you like make a space between line 7 and line 8 and then?
Actually, you just start writing it here. This is a description of the class. And you can see, like in IntelliJ, it automatically gives you the asterisks, which is very nice, right? That's another reason to use IntelliJ, right? Yeah, and so methods you document in the same way. In fact, when you document methods in this manner, hey, look what it's done. Parameter args. It's actually picking up what the inputs to the method are and automatically putting that into the documentation for you, right? Which is cool and nice. It's very, very convenient. Make sense? Okay. Good. What else do we have time to talk about? Okay. I'll show you very, very quickly. We'll do this again tomorrow, but I'll show you very quickly what this is. So these are like not considered good to use. Please don't use them except in the simplest of programs. You can tell the program to pause its execution for X number of milliseconds using thread.sleep. In order to use this, you have to put throws interrupted exception at the end of public static void main for reasons I can't get into until week 11. But if you just, if you write the magic words, throws, what was it? Interrupted exception. There you go. You can do stuff like this. Oh, and by the way, if you type S out and tab, that's a shortcut for system.out.println. Yay! So, let's see. Why did the chicken cross the road, roll in the dirt, and cross the road again? Thread.sleep 2,000 millis. Okay, very quick, all right? In IntelliJ, it pops these little labels in. It tells you what the name of the argument you're supplying is. This is not a part of your source code. It is not in your file. It is an annotation. That often confuses people. Like when people think I typed that, I didn't type that, all right? It just popped it in automatically. If you're following along, don't copy down millis colon. Okay? Good. Common pitfall. So why did the chicken cross the road? That's out. Because he was a dirty double crosser. Asks the question, 2 seconds later gives the answer. Make sense? a lot of the exercises in the first week exercises use the sleep method for various things, but I guarantee you won't use it at all past that point. Okay? Nor should you. Okay. Any questions before we get out of here? Nobody wants to risk delaying exit any further? Yes. All right. If you have any questions, I'll be here tomorrow. I hope you will be too. Thank you very much, and I'll see you guys tomorrow. So, this is a 3-hour section, 3-hour class. Because 3 hours is an awfully long time, toward the middle of the class, we'll have a 15-minute break, in accordance with biological necessities, at some point which is convenient. And that's what we're going to do. So, yes. So today we're going to further explore the Java programming language. We'll do some programming exercises on the lab computers. Please ensure that you have IntelliJ up and open on your lab computers. Let's see here. Here we go.
So are we just going to call this one lab exercise?
Yeah, or you can call it week 1, 2, or week 1 continued, something like that.
See how we just open it up and go new project?
Yep. Yeah, like this thing isn't picking up the other display, so probably someone's been messing with the cables. People occasionally do this when they don't have an HDMI cable. They just kind of sneak it off of this, and then maybe they don't put it right, back in the right slot. I don't know, maybe. But restarting it didn't work. Eh?
You try clicking text display.
Um,
Sometimes that works.
Text display.
The text display.
Oh, detect display. Yeah, nothing.
No?
Yeah. So, I feel fully justified in calling IT. So, I guess for the time being, if you could just follow along on the course notes, open them on your own computers, and we'll proceed along that.
I wish these computers would load anything at any given time. That would be kind of nice. To have a computer where that would be loaded.
You're asking a lot.
Yeah, I am asking why you're right.
You're asking a lot because these are Windows machines. You have to, take them into account.
I'm running Windows on this laptop and it's doing fine.
I have to take time
Yeah.
to bloatware I'm living right now, okay?
Week 1.
School computers
All right.
are the worst with bloatware.
So, if everybody could please navigate to modules 1, under week 1, input processing output, 1, guide week 1, which is a title containing at least a little bit redundancy there. So, we left off with commenting. Let's continue our discussion to variables input and output. So, variables then. So, one of the things that you'll notice about the Java language almost immediately, I pounded this topic a little bit yesterday. Sorry, yes, you have a question?
Do we also make a new Java class or no?
Oh, don't worry about that for the time being. Just listen to me talk for a bit. So, one thing that is very important, kind of important conceptual work that we have to get out of the way before we do anything else, is we need to discuss the difference between a static and a dynamic type system. So, definition. Under a static type system, the types of variables may not change during execution. Good morning. Under a dynamic type system, the types of variables may change during execution. Java uses a static type system. Python, JavaScript use dynamic type systems.
Sorry.
No trouble, come on. So, because the type system is static in Java, we must declare all of the pieces of memory that we use with their appropriate data types before use. Right? This is the biggest difference that we will see between what we have now and what we have going forward. Hello. I look like it's also not detecting the display. If you go to display settings. So I think maybe someone was messing with cables. Thank you very much.
Here.
Thanks. So, for example, in Python, we might say something like x is equal to 5, perfectly nominal variable declaration. We may then say x is equal to a string containing the letter x. This does not pose a problem. Python simply adapts to the newly assigned value and the newly assigned data type without any trouble. This, however, is a big old syntax error in Java. In Java, you wouldn't even be allowed to do this. You're not allowed to assign to a variable that's undeclared. So this is the biggest difference with Java. We take instantiation as a separate and distinct step from declaration. Declaration and instantiation are different things. They can occur on different lines of code. So, when I say int x, I am declaring a variable of type integer named x. I may then assign to it without causing an error. So far, so good. It's common to put both of these on the same line. Int x is equal to 5.
Let's just talk about that.
Yes. This is common, but it's not required syntax, right? In Java, when you declare a variable, it's given a default value if you haven't declared something yourself explicitly. What the default value is depends on the data type. In the case of integers, it's 0. Right? So you get 0 by default for free. So, as a matter of technical fact, if your opening statement is int x is equal to 0, this is technically a redundancy. However, I would say it's probably a good redundancy. A good way to program in general, not just in Java, is to try to not rely on implicit rules. Don't rely on the language doing stuff that it does automatically and leaning on that, right? If it's important to the program that the variable be initialized to 0, it's more clear to everybody who's reading it if you actually explicitly state this variable is initialized to 0, even if it would have gotten there anyways. Does that make sense? Because we are focusing not just on, ooh, there we go, very good. We're focusing not just on writing code that works. We want also to write code people can read. And when we say people, we include ourselves in that. Right? Because when you write a program, you don't know how long it's going to be until you look at that code again. It might be a couple of days, it might be a couple of weeks, months, or years. Are you going to remember everything about the little program that you wrote 2 years ago? Not likely. So documentation is not just for other people, documentation is also for yourself. Documentation is also not only just comments, right? Comments are very important in documentation, but clearly written code itself is also important for conveying the meaning of a program. So, that's why in this classroom I always stress and I emphasize writing code which is clear and understandable versus like code that's like compact and clever, right? A lot of the programs that I put on the board, you could write much more compactly, but perhaps not more simply, right? I know we're all programmers and we love to save keystrokes, but there are times when you need them. Make sense? Are we all good?
I'm just gonna, one of the audiovisual guys is gonna come by. Just the sound is not working, so he's
Oh.
gonna come up in a few minutes, but
Sure.
like the projector is going, so.
Wonderful. Ah.
Yeah, like the transmitter on the Ethernet had to wiggle it a bit and like it's the cable. Yeah, and then also, there's no sound here. It picks up Epson PJ, but the co-locates over here. We're just gonna check out the sound.
Thank you very much. Yeah. I'm just going to bring up the slide. So,
Check this. I'm just gonna check the sound here. Just
sure, yeah, I'll doing a sound check. Don't you hate it when people mess with the seconds?
yeah. I'm clicking, but nothing yet.
Hang on.
Okay.
Oh my. We've got it till noon. It's a 3-hour class. We actually don't need the sound.
You don't need the sound.
Yeah.
You don't have the sound?
Yeah, no. Yeah, we don't need the sound.
Yeah, I asked the
It
point.
doesn't sound that.
Yeah, then you can come back, yeah. So till 12, yeah, till 12, yeah. Yeah, we'll come back.
Thank you.
Yeah.
Appreciate it.
See you in a bit, yeah.
Thanks. Okay. Totally justified to call IT. They had to go into the cabinet at the bottom. Okay. All right. So, Java is a language that has a type checker, right? So let's very quickly talk about the stages of compilation, right? So the first stage of compilation is pre-processing. The first stage is pre-processing. Pre-processing requires the removal of comments from the source code and the processing of any macros. After this, the program undergoes a process called tokenization. You could also call it parsing. The purpose of this is to take the raw textual content of the program and convert it to meaningful programming symbols, right? When we take a statement like int x is equal to 5, there are 5 symbol groups going on here, 5 tokens, right? Token, 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 token. Each of these have meaning inside of the programming language. Parsing or tokenization is breaking a string into tokens. Does that make sense? The next step that you have after that is type checking. This is the first round of processing, applying meaning to the tokens of the language. We see, for example, that this variable has been declared with the data type integer. Therefore, if we, going down the program, ever encounter something like x is equal to false, right? We know that the data type of this literal contradicts the declared data type of the variable. This, therefore, is a type checking error. Does that make sense? This is, of course, the simplest example of it. The Java type checker also does things like ensuring that you're calling the correct methods on the correct objects, verifying that objects are of the class that they say they are, these types of things. But the type checker is something you now have to worry about. In Python, you did some dynamic type checking, but this is strong static type checking. This is a pre-processing step. Before the program even comes close to being executed, you have to satisfy the type checker that you have written a correct program. Does that make sense? Question?
Well, what exactly determines what value would be, like, what determines if it'd be true or false or not? Or true, just true or false, what will determine it, since
What would determine if what is true or
it's
false?
like the integer, how would the integer determine if x would equal, true or false?
Oh, the integer, so the reason for this contradiction, you're asking?
Mm-hmm.
Well, so basically, when you encounter a literal, right, this literal belongs to a set. The set is that data type, right? Does false belong to the set of integers, or does it belong to the set of booleans?
The set of booleans?
Right, so that's not the set of integers, so that's a type error. Does that make sense? Yeah, good. So, once the data has been type checked, I missed one in here. Abstract syntax tree construction. Gotta have that first. Once it's been type checked, we enter the phase of generation. This is the reorganizing of the abstract syntax tree into something resembling machine code. Once you've generated the machine code, you then link it to other machine code, other compiled source code. This is normally kernel functions. After linking, you then execute. IntelliJ kind of takes the compilation phase and integrates that with execution, but this is of course not how compiled languages necessarily work, right? You can compile it as many times as you like before executing it once. You can execute it as many times as you like after having compiled it once. Compiled languages. So, all right, sounds good. Any questions about data types? Good. Let's. I have a few more things to present to you, and then we can try some examples. So, moving right along, we are going to talk about basic command line interaction. Taking input. Taking input is something that you'll have to do frequently. It's the sort of thing that occurs a lot more frequently in school assignments than it does in the actual real world. Most of the programs that you will write will not be command line based programs for interaction with a user with a keyboard. But, you know, a certain number of them are. So, this is how Python takes input. Review. You have this handy little input function. It automatically scans standard input for characters entered by keyboard and processes them, resulting in a string output, right? In Python, input always gives you a string, and if you want it interpreted as some other data type, you then manually convert it.
Mm-hmm.
I'm sure everybody remembers.
Yep.
In Java, because this is an object-oriented language, we need an object to read stuff. So, we declare a new scanner object. This first line, by the way, is a typical line which takes a class and creates an object from it. We're not going to talk about classes and objects until week 3, so for the time being, just copy that down. Just, repeat the magic incantation into your IDE, and we'll explain it later in more detail. But essentially, this is the name of a class. The new keyword tells you you're creating a new instance of this class. Scanner input, we are saying we are declaring a variable of type scanner with name input. So the input variable is now an object. We can call methods using dot syntax from this object, as you see down here and here. We also declare integer x. This is where we are going to be storing the output from the input next int method. Does that make sense? So, within the input object, we have a collection of methods which read various data typed things from standard input. Standard input, by the way, is the thing that you enter the keystrokes into. We can then assign that to a variable, and then once it's a variable, we can do anything we like with it. Make sense? Shall we try it out? Let's try it out. So, in your IntelliJ project, please create a new class . It doesn't particularly matter what you call it. Let's call it week 1. There we go. Can you see this at the back? Is this a good level of magnification? Awesome. So, public static void main tab. There we go. So, we wish to create the scanner object in order to take input. Scanner input is equal to new scanner. Now that's interesting. It just did something without me asking it to. Does anybody see the line that was automatically added? Did you catch that? Try it yourselves.
Import.
The import statement at the top, yes. So, it's probable that through your Python class you probably didn't have to do too many imports, right? Did you, how many? Not really?
Zero.
0? Okay.
Unless you have to do a random, actually.
Yeah, you
Unless you have to do a random.
Okay. So, importing is fairly simple. All it's really doing is finding this file and it's dumping either references to compiled functions or the source code itself, depends on how it works, right? This is where scanner is defined. In IntelliJ, when you enter this scanner object, it automatically adds the line which imports it. Question?
What's the title for the file? Hold on, I can't really read it.
Oh, I just called it week1.java.
Okay.
So, that's another advantage of using IntelliJ. In other IDEs, you would be responsible for remembering to include that import statement yourself. The scanner requires, basically we need to tell it where to look for input. System.in, which is the input stream. I think that's correct. Let me check. Yes, good. So, the tooltips are extremely useful. In is an input stream. There you go. So, we have declared our scanner. Make sense? Any questions so far? All right. We might then write one of those extremely simple tutorial programs, something like enter a number greater than 10. we now want to acquire input from the user. The way that the slides do this is to declare something int x is equal to nothing up front, but as a matter of fact, you can do that in line as well. Int response is equal to input dot ooh. Now that is a nice, tasty list of possible autocompletes now, isn't it? Notice, we have all kinds of things here. Next int, next byte, next short. Has next, next boolean, next double, next float, next line. Notice that it tells you what the return type of each of these is. Right? If you want to read a double, next double. If you want to read a string, next line. Make sense? So, in our case, we're going for integer, however. There we go. So, for the time being, let us echo back the response that we've given, just to make sure everything works. A thing which is convenient about Java that Python doesn't do, when you, first of all, the plus symbol is string concatenation. You guys know what concatenation is, right? You've heard the term? Good. When concatenating a string, or concatenating something to a string, Java will automatically convert it to a string, using the definition, whatever its defined string conversion is. And later on in the course, we will learn how to define string conversions for things. Make sense? So, let's run our program. Week 1, run. Low access. Uh-oh. Cancel. Alright, it worked anyway. Great. So, enter a number greater than 10. 12. You said 12. Very good. Very, very good. Not too bad. So far, so good. Right? Everybody get that working? Anybody having difficulty? Oh, yeah, right-click the source. New? Not double-click, right-click. New? Class. Call it week 1. So, yes.
It's not letting you run it.
Open the folder. No, source. Try right-clicking that one.
Oh, alright.
Yeah. And the computer is always right. It's never a matter of the computer won't let me do X. It's always a matter of I'm not doing it quite correctly.
What do we do with this firewall thing we had pulled up?
Just cancel. Just click cancel and it'll work anyway. So, all right. So here's an interesting thing. If we rerun the program, what do you think happens if I enter something that's not an integer? For example, potato. What do you think is going to happen? we get a program crash, like an actual honest to goodness, that crashed the program. So, welcome to Java's exception handling mechanism. Next int expects an integer. If it doesn't get an integer, it raises an input mismatch exception. Now, we're not going to learn how to handle exceptions until much later in the course. So for now, I can just point at it and say, this breaks your program if you don't handle it. We'll learn how to handle it later. But just keep in mind, when something says it returns an integer, it doesn't return anything else. It will break the program before it violates that rule. Does that make sense? Any questions? Okay, very good. So, in this program, we are supposed to be entering a number greater than 10. But we're not checking that. How do we check things? Like maybe our batteries? Everybody's a little bit low energy at the moment. How do we check for things in a programming language? If statements, yes. So, good news everybody. If statements look pretty much exactly the same as they do in Python. The only difference is they have curly braces. So, if x is greater than 10, or x, I didn't call it x, response. Thank you. If response is greater than 10, s, there we go. Hooray! You can follow basic instructions. Otherwise, uh-oh, perhaps you can't follow basic instructions. So, if we execute this, entering a number less than 10, we get the bad ending. Rerunning this, entering something greater than 10, we get the good ending. So far, so good. So, any questions? So far, so basic, right? Good. So, let's see here. So, back. There we go. We're going to take a little bit of time now to do an in-class exercise. We're going to try a few of these. So, let's do this one, B. Write a program that displays the following to standard output with a half-second delay between each line. I think you guys could probably get that accomplished in 5 to 10 minutes. Yeah? All right. If you need to make a new class to do this, if you want to keep all of your work for different things in different classes, I totally encourage that. All you have to do is make a new class give it a main method, and then right-click to run that from your project view, and then that's how it works. So I'll give you 5 to 10 minutes. Let's see if you can get that working. Okay? Question? All right. So, general comments on what I expect your code to look like, right? At this stage, I don't have many expectations for what your code will look like. My expectations are primarily, does your code work, right? But in my opinion, it's an inferior way of teaching programming, but it's a way that it's a simplification mechanisms that some professors use when they're teaching coding. When they teach you how to code, they teach you if you're not using the exact program structure that I'm using, then I'm not going to grade it well, right? It's like, if you don't declare this thing here, that thing there must be immediately be followed by that, this, and the other. It's like, no. Basically what that means is it turns your assignments and tests into guess the instructor's program, right? But this isn't programming, right? This is an inferior way of learning how to program. What you need to learn when you're programming is the specific function of every statement you use in the language. You need to be able to compose those statements into a program that works. That is your job. Memorizing things at the level of basically, if any of you take this program back to your place of residence and drill this until you've memorized it, I will be very disappointed. Alright? Because I'm not trying to drill you on specific programs. Right? There are 100 squintillion programs. You can't learn every one of them. What you can learn are the principles that underlie the construction of things like this. And that's where I focus my instruction. Therefore, I do not expect you to have any particular programming form when you're submitting assignments. You can use, basically, if you already know some programming, you can use everything you know to its utmost. I'm not scared by you having knowledge that you didn't get from me, right? There are a couple of things that are telltale signs that you generated things with the chatbot, though. So if I see those in your code when we do code review, I'll be like, explain how that works. And if you can't explain how it works, I'll be like, well, you didn't get it from me, and you can't explain how it works, so where did it come from? Right? Which I think is fair. I think that's fair. But no, I'm mostly interested in, does your program work? Period. Does it perform what it's supposed to perform? Given this input, do I get what I want as output? That's what I'm grading for, right? Now, in Java, there are a few things you have to, modularize your code according to classes, the way that was taught in class, right? It's possible to write Java programs that produce the expected output without even using the class mechanism, right? You can do everything as if statements and loops inside one gigantic main method, right? That's not Java. That's not what we're learning in class, so that's also going to be you have to use the stuff we learned in class, right? Which is also fair. It is a true thing about programming that actually, if you have if statements and loops, you can construct literally any program that can be written by anything else. That's a mathematically true result about programming languages. So, that's why the basics are so important, because you can literally construct any program from them. But, the point of this course to some extent is object-oriented programming. I need you to demonstrate that you have accepted the concepts of like association and inheritance and that sort of thing, right? Which I think is fair. But you have a fair amount of latitude with respect to how you come to a solution. So back in the day, I used to do martial arts, and I haven't for some time. But back in the day, my teacher told me this about when you're trying to acquire a skill, and I think it applies just as much here in programming as it does in martial arts. He said there are only 3 beginners, there are 10,000 acolytes, and there are 3 masters. Right? So what that means, when you're first starting something, right, everybody kind of makes the same beginner mistakes, right? So when you're just initially starting something, you haven't had enough exposure to really develop your own style, right? You're a person who's been programming for 3 days, sitting next to another person programming for 3 days, they're going to make very, very similar mistakes, right? It stands to reason. As you gain experience with it, you will develop your own style of programming, right? This is good and healthy. The thing that all of you should be doing right now is working on your personal style, right? Now, as you develop your personal style, you'll be, like I remember when I was in my early coding days, the thing I would do is like, I would write a few lines of code, and if they didn't work, I would like write a synonym for that. Like I'd try a different type of loop, or if a while loop wasn't working, I'd try a for loop, see if that worked. And rather this was kind of a dodge because I was like not sufficiently good to really understand what I was doing, so I couldn't fix my loop, but I could write a new loop that I thought replaced the old functionality. Eventually I was able to like fix my own loops, and eventually I was able to not really make too many mistakes when I wrote them, right? But in that initial phase, it's like when I sort of found a consistent way of doing things that worked for me consistently, that was me developing my programming style, right? But that came after a period of exploration, right? I was exploring which code constructs work natively with my brain, right? So that's what happens as you gain skill. Your code style will separate from your friends or things you see online. You'll have your own distinct style, right? Everybody in this room should be except for me, should be in that expansion phase, right? Unless you've been coding for years and years and years and you've already gone through it, right? I don't know how, some of you at the back seem to have been coding for a few years now, so. But you kind of go through that with each language you learn too, But, so once you have acquired an intermediate level of skill, then you start saying to yourself, okay, but it would be a little more efficient if I did this, right? So you're not focused anymore on does it work, because you can get your programs to work consistently now, right? What you're focusing now on is improving your style, right? Finding the little things that you can shave off that improve runtime efficiency, improve readability, clarity, all of these types of things, right? Like, when I code now, I code like a textbook, Partially this is because I'm an instructor. I teach for a living, so, code which is like in a textbook is often clearer, so that's what I gravitate to, because, I see fewer faces of confusion in the crowd when I code more clearly, right? But, like, basically, you have to kind of think of it like your style, as it develops, will contain a lot of inefficiencies, right? And the inefficiencies are part of what makes it unique to you. As you go through and like prune off those inefficiencies, eventually your style comes to more and more resemble people who've gone through the same process, right? Who at one point had a very distinct style, but as you prune your styles, they gradually converge on each other, right? So a person who's been coding for like 30 years will greatly resemble someone else who's been coding for 30 years, but someone who's been coding for like 5 years, right, is probably going to look very different from someone else who's coded for 5 years. Does that make sense? So, for me, you should be in an exploration phase. This is appropriate, good, and correct. So, explore. Try stuff out. Submit stuff, you know? Like, I'm not going to try to force you to code like I code. That's to, deny you the creative exploration and the enjoyment of the discipline, right? Like, if you want to do this for a living, you have to find a way to, you have to find it enjoyable in some way, right? So, I don't want to squash all of your your budding, affections for this by being overly strict about how it is that you construct a program, The philosophy is every statement does something. Understand what the statements do. Don't worry too much about memorizing patterns of these, right? Basically, if you're a coder worth your salt, you should be able to regenerate the algorithm, not from memory, but from the problem, right? And that's also how the testing thinks about coding, right? In JavaScript more than in this class, but, makes sense? Okay. I'm not trying to, my goal here is not to, feed you into the factory and pump out perfect reproductions of myself, Okay. Good. All right. So, it's 10:30. So, I'll come around to you. Let's have our 15-minute break. When we come back, we will discuss JavaFX, and we'll do some more exercises. Okay? Sound good? Okay, good work, team. There we go. Very good. So, we need to talk about JavaFX. So, it's a little complicated. What is it? JavaFX is a series of Java libraries where you can draw pictures and create graphical user interfaces. If you've ever heard of the Java Swing library, it basically does the same thing. The underlying basis for it is basically SVG graphics and HTML components. So JavaFX is kind of like another way of going about the things that we're going to do much more simply and directly in JavaScript. But, there's kind of this interesting point in the middle of those two courses where they kind of they kiss and then they go apart again for the exams. JavaFX. This will be your first introduction to it, though. So, let's see here. So, step number 1, we are going to obtain the fx graphics template.java from Canvas as starter code. If everybody could please navigate to Canvas now and get that starter code, that would be fan-flippin-tastic. You'll find it in the example code for week 1, the zip file. There we go. Extract it. Extract. There we go. Week 1 code. You will see fx graphics template.java. In your existing Java project, select that file and drag and drop it into the source directory. It must be dragged and dropped into the source directory. You will be asked to refactor it. Just say yes. There we go. You now have the FX graphics template. There we go. You shouldn't see any errors at this point. If you see errors, then there's a problem.
Sorry, put it under source.
Yes. Drag and drop it into the source directory. So let's see what we get.
Refactor.
Yes, when we run the code. Oh, it's running the wrong one. There we go. Run that code, please. You can see we get a little pop-up window. That's just a blank region of, yeah, just a rectangle. We have gotten a rectangle. Question? So because this is on your own laptop, this might mean that you're not importing the Liberica Java library correctly. This is something that I probably can't solve at the moment. Try reinstalling Liberica. Did you install Liberica? It may just be a matter of create a new project and make sure that that's the version of Java that the project is applying to. If you had a pre-existing version of Java, it may have selected that as the default instead of the new one. That would cause that error. But basically it's saying Java FX isn't found, right? The whole reason we have you download Liberica is because that's the one with Java FX. Okay? All right. Any other questions? Okie dokie. So, all right, so far so good. We have a rectangle. Much of this code, unfortunately, I can't at this point really do a breakdown of the code yet. We will be able to do that by the end of the course. By the end of the course, you should understand most of what's going on here. But I'll point out a couple of interesting, useful features. Right here, width and height. This is where you are declaring the size of the canvas. So if we modify these values, we will get a window of different sizes, right? So if I set this, for example, to 600 by 600, and rerun, stop and rerun, you can see that has changed the size of the window. Another important one is the title. This is the title in the taskbar, toolbar thing for the window. You can set that, perhaps week 1 example. Week 1 example. Right? So far so good? So, when you're drawing stuff on the canvas, you will be doing so through the graphics context object. All of the methods that I'm about to show you are methods of this object. So, when we want to draw a rectangle, we must start by invoking that context. GC dot. Now you'll see a whole bunch of methods. Your basic one is fill rectangle. This is draw a rectangle that has an interior color, right? So, you'll see that the tooltips provide very useful contextual information for what this method expects. X and Y positions, both expressed as doubles, and width and height. So, I'm going to, let's just put a pin in what on earth is a double for now, and it's a float, it's a number with a decimal place. Let's just give it some values. Say 50, it also accepts integers. 50, width 100, height 200. Execute. Ta-da! Yes.
Is there any way you could zoom in further?
Yes.
In the text, please?
Certainly I can. Is that better? A little more?
I might need to put on my glasses.
I can only go so far before I lose too much of the screen, you know?
I think that's okay.
Okay, good. So we have managed to draw a rectangle. Ta-da! Any questions so far? So a couple of things to note about the geometry here. So I have something that looks like this. I had stated that x is 50, y is 50, width is 100, and height is 200, I believe. Yes? So, the question is, x and y relative to what? Right? If this were a math class, the origin would be located right here. Right? Is the origin located right there? Based on the position of the rectangle? Where's the origin? Up here, that's right. So, the point 0, 0 is actually located in the upper left-hand corner of the screen. If we rerun this so that we are putting the rectangle at 0, 0, you can see it snugs it right into that top left corner. Now, that also means that the registration point of the rectangle is not the center of the figure. Right? Otherwise, we'd only see half of that rectangle. Well, actually, we'd only see a quarter of it. Right? One quadrant, as it were. The registration point of the rectangle is the upper left-hand corner of the rectangle. So, previously, when it was 50-50, this distance is 50, this distance is 50. Note, this is not negative 50, it is positive 50. So, y values increase as they travel down. This is reverse from what you would expect, right? Normally we think of y as being like positive y as traveling upwards, but in this case, you start at the top and travel down. Does that make sense? Very good, very good. So, yeah, just a little geometry for you. Width and height, I think you guys probably, I don't have to comment on it. So, question?
Yeah. The original FX graphics template isn't even working. It won't let me launch it. Or like execute or whatever.
Let me see for just a moment. Are you working on your own laptop?
Yeah. But I'm using IntelliJ.
Are you using the Liberica library?
I am.
You are. Interesting. Is it in the source folder though? It looks like it's not in the. Oh, I'm sorry. Yeah, you've got it in the source folder. Yeah. Is this the community edition?
They got rid of the edition. It's all just on one thing now.
Oh, okay. Okay. Let's see. I don't think I can fix it right now, though. It's also not saying that. Where's the error?
It's not showing there at all.
Why wouldn't it be showing the error?
I'm saying.
Okay, here's the thing to try. You can actually create a JavaFX project.
You're right.
So try that. If you go to, oh, yeah, there you go, very good. Advanced settings. No, yeah, there it is. Try that. Try copy pasting the code into one of those. All right. So, I should probably kill the lights a little bit. There we go. That's better. So, circle. Circle is very similar to rectangle. Technically, it's an oval, but technically, it's not an ellipse. Ellipses are something else. We have 200, 200. Width will make 200, and height will make 100 this time. Try again. Oh, gets me every time. Need a semicolon. There you go. We have an oval. So far, so boring. So, next thing to know is how to set colors. So, at this point, it's somewhat important to understand how JavaFX works. So, there are two color parameters, stroke and fill. Stroke is the outlines around things, and fill is the interior color of an object. This is fairly, like if you've ever worked in a vector graphics environment before, this should be fairly, bog standard. So when you draw a figure, the color of that figure is derived from the stored stroke and fill values. That's why we're not attaching colors to these operations. So if we want to set the fill color, gc dot set fill color. Now this is your first major pitfall. If you click the wrong thing here, you can screw things up in a way that's difficult to fix. Not impossible to fix, but difficult to fix. See this, this drop-down menu? We have two definitions of color available. One is correct, one is incorrect. JavaFX.scene.paint is the correct place to find it. That's the JavaFX library, that's what we're using, right? However, if you accidentally click or enter this one, there will be no apparent difference here. These are in fact very similar libraries, but basically you'll perform a weird kind of binding in IntelliJ where it will think that half of the things you're talking about are in the AWT library rather than JavaFX. It will also add a bunch of import statements at the top to include AWT library stuff, but these two libraries are incompatible and do not communicate with each other. So this thing is not satisfied by that color. It will break and it just messes things up. So whenever you get a drop-down like this, always make sure that you are selecting the JavaFX version of whatever it's given you in the list. Make sense? Hopefully. So, yes. Now, within the definition of color, we get quite a few definitions. We also have some color conversion functions, but let's just look at colors. The very first one there, Alice Blue, or as I like to call it, the hello world of CSS colors. You guys remember that one from CSS, HTML and CSS, I hope? Yeah, they probably used it a lot, right? It's probably just because it's the first one in the list. But the color set we are working with is the CSS color set. So you can pick whatever you like. Dark orchid, you know, Gainsborough, light goldenrod yellow, peach puff, which is an awful color. I think peach puff is my most hated CSS color, actually. Sea green, there you go. Boom. Sea green. Make sense? Now you'll notice that we have fills but no outlines here, right? We can set the outline in the same way. Oh, but before I get to that, notice one thing here, right? Although my statement setting the color occurs before the rectangle, notice that both the rectangle and the oval have picked up the color, right? That's because this is setting the fill color parameter in the graphics context. It's not like applying it to the next thing, right? If we want to change color between the drawing of these objects, we need to insert another set fill statement between them. Does that make sense? Good. For example, color dot steel blue. There you go. You'd think steel blue would be a little more gray than that, you know? Right? So, let's do outlines. GC.setStroke. Color dot, oh, I don't know. Gainsborough. I don't even know what Gainsborough is. Let's try it. Ah. Something. Yes.
Something weird's going on with mine.
Okay.
So for some reason, it says there's something wrong with line 36. Not sure what it is. The word color is the one outlined in red. I don't know what's wrong with it.
That is he. Yeah, it's possible you pulled it from the AWT library.
The what?
Just have sure, so there's no fingerprint there right now.
No. Okay, well,
I still have a fingerprint on the rest of mine.
there you go.
It's just like right now.
Yes.
What's the command to copy a line fingerprint there?
The command to copy a line, ooh, I don't know.
So
Is
you,
it Control G?
I saw you just do it, that's why I was.
It's just straight up not letting you watch.
That's not one shortcut. What I do is I home, hold shift, and that's my keystroke combination. It's a good one to pick up because it works no matter what editor you're in.
What was it again?
You either press end to put your cursor at the end of the line or home to put your cursor at the home, hold shift, and then press the other one. That highlights one line. Yeah. Man, like, if you start using like the home tab, page up, page down, like those guys, like, you become very powerful very quickly as a programmer. Yeah, your like power level as a programmer is like directly correlated to how well you can use home and end, how frequently you use find and replace. Like find and replace is your best friend. It's your best friend as a programmer. I said yesterday that the machine is not your friend. I will make an exception for find and replace. Especially, if your engine, if your editor supports regular expressions, so good. I think I have to also stroke rectangle. That'll do it. It looks like something. It did something. Okay. We're gonna increase the line width. I think that's the problem we're having. Set line width. GC dot set line width 2. There we go. See if that does something. Yeah. Oh yeah, Gainsborough's just like a horrible, like slightly off white color. Okay. Alright. Well, you know, that's what I get for trying new stuff. Coral, that should show up. Oh yeah. We'll wrap the sea green in coral. There you go. Ta-da! Outlines. So, but here's a question. Will it work without that? Boop. So if you want the outline, you're creating a stroke rectangle. If you want the interior, you're creating a fill rectangle. Make sense? Of course, I think there's one that's a combo of those. Just a minute. Stroke, fill, stroke, fill, stroke, fill. Okay. That might be both. Let's see here. 400. No, 0. No, 50. 400. 60. 60. Let's see here. What do we get? Nope. Okay. Never mind. Just trying stuff. Okay. So, if you want filled, use fill rectangle. If you want stroke, use stroke rectangle. All of these functions have, a variant of both. If they have area. There are also there's also line, which allows you to just make a line between 2 points, right? So GC dot stroke line between, for example, 40, 40, and 70, 70. Oh, gets me every time. Too much programming in loose languages. There you go. See, you can just draw a line. Make sense? Okay. Draw a snowman. Go. That's your exercise.
Do you mind just scrolling up to the top?
Sure.
We did this in Python.
Okay. Question?
I could not tell you what the issue was, but I solved it, so.
Yeah, see?
Java.awt, that's the thing I was talking about.
So, try removing it.
JavaFX is one.
Ah, see? That's what it has to do now because there's been a piece of code put in. That guy. You gotta get rid of that. That one too. Get rid of those. They put those in automatically when you select the AWT. Let me see. So if you go, make sure it's JavaFX. Dots. For now. No error. Sound good? You don't have to make a snowman. If you want to make like a house or something, you can do that. Whatever you like. One of the exercises in the exercises is to do the Olympic rings. But that's actually like a much more complicated image than you might expect because like on the official Olympic rings symbol, it's not actually just overlapping circles, right? Like you have a gap where like one is supposed to pass through the other, which is actually like, that means that these aren't even circles, these are arcs, right? Which, if you want to do the simplified version, I'm totally okay with that, right? But, if you want to make life complicated because you hate yourself, you feel free. Certainly, increasing the difficulty of the exercise increases the, the value of it as an exercise. Left my tea somewhere.
Right here.
Ah, thank you.
Did you see the rail on it? Like drawing it?
Drawing what?
You like drew a line on the thing.
Oh, it's just stroke line.